This is GCSE Physics, this is Particle Model Lesson 3, and this one is Density Lesson 2, or Part 2. Objectives are to explain how we measure the density of irregular and irregular objects. If you haven't watched the previous lesson and you're not aware of what the density equation is, I suggest that you go back and watch that one first. If you do know, then let's continue. So density of irregular objects like this piece of wood. So to calculate the density of this object, we need the mass and the volume, because obviously the density equation is mass divided by volume. To do that, we need the following. So to calculate the density of this object, we need the mass and the volume. So we use a ruler to measure the dimensions of the regular object and calculate the volume. So we've got length, width, and depth. And obviously to find the volume of a cuboid, we just multiply those quantities together. So we can do that using a ruler. The second one, that is not a weighing scale. Never ever call it a weighing scale. Okay, we use a balance to measure the mass of the object. You have got to say balance in the exam. If you say weighing scale, the examiner, well, we'll just give you 0. All right. So you'd measure the volume using a ruler, measure the mass using a balance, calculate density by doing mass over volume. Pretty straightforward. Remember to pause at any point to make any notes. So about an irregular object. So as a rather funky looking stone. So to calculate the density of this object, we need the mass and the volume yet again, but we've got a problem. And the problem is what do we measure with the ruler? Ideally we can't, so we have to use a different method. And this is the method. So when you sit in a bath, what happens to the water? So I'm assuming that you've all had a bath before, unless you just live on showers. When you sit in a bath, what happens to the water level? Yeah, the water level rises, doesn't it? So your physical mass has displaced a body of water, and essentially the amount of water that's displaced is the volume of the mass that you've put in the water. So let's get that in more simple terms or straightforward. So how do we find the volume? So we need a eureka can, a measuring cylinder, and some water, and ideally, if the object's small enough, piece of string. So your measuring cylinder on the left, we've got the eureka can on the right hand side, and then our object, the stone, on the right hand side. And this is what you do. So procedure, find the volume of an irregular object. So you fill the eureka can with water and slowly lower the irregular object, in this instance the stone, into the water using a string. Water will be displaced and flow into the measuring cylinder, and we call that the displaced water. So the amount of water in the measuring cylinder can be known, and the amount of displaced water is the volume of the irregular object. So then we've got the mass, obviously because we've used a balance to measure the mass, and then we've got the volume from the amount of displaced water. So once again, we can use the density is mass over volume equation to calculate the density. So what I'm going to give you now is a 6-mark question that talks about these methods, or asks about these methods, and you've just got to write a coherent response. So here's an exam style question. So describe both methods to obtain the density of these objects. So we've got a regular steel type thing on the right hand side and a bust on the left hand side. So what are the methods to obtain the density of these objects? So let's pause and do that, and I'm going to take through show you the mark scheme on the next slide. So for the piece of steel, you'd measure the mass using a balance. Don't say weighing scales, remember. You'd measure the dimensions using a ruler and calculate the volume by doing length times width times height. And then calculate the density by doing the mass divided by the volume. So as you can imagine, that's more than likely your 3 marks. The stone bust. Measure the mass once again using a balance. Put the bust in a eureka can. Collect the water in a measuring cylinder and obtain the volume. Remember, the amount of displaced water will be equal to the volume of the bust. then we can simply calculate density by doing the mass divided by the volume. And that's it. Now you should be able to give a coherent method to measure the density of a regular object and to measure the density of an irregular object. Thanks for watching, and I'll speak to you soon.